In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work. So for example 1, you were given this figure up here, which consists of 3 lines intersecting each other at different points, in various points that are on the line, or in points of intersection B, C, and F. And you were asked to identify which of these is the result of either the union or intersection of what you see over here. So for this first one, you have the open-ended ray FE and ray FG. So I'm going to have those show up here. The open-ended ray FE would be everything, from F in the direction of E and going on forever, with F excluded. And FG would be, starting at F, including F, and moving this way. Now the reason why I did all the same color is that I do have a union sign here. So because F is included in this one, it's going to be included in the union. And as you can see, this entire line is the result of the union. And this line could have many different names to it. I mean, I could call it line EG. I could call it line or FG. I could call it line BE. Of all the things that are down here, well, first of all, there's only one full line down here, and that's BG. It's just those R2 points that are on the line. That is one of the many names I could give that particular line. So BG is what goes over here. For the second one, I'm looking for the intersection of 2 open-ended rays, BD and CB. So if I put BD in and I put CB in, I'm putting it in a different color so you can see it. Now, I want where the two colors could both be seen and overlapped. That means that since B is not included in both and C is not included in both, although they're included in the names, the open-ended circle indicates that that endpoint for that ray is not included in each one of those instances. And that because of that, those are going to be left open-ended. It's just the segment BC without the endpoints that I'm looking at. And that's what this symbol is here. So that's what goes in there because it's the intersection. If it had been the union, it actually would have been this entire line, including those endpoints. But because it's the intersection, it's only going to be those ones between. And I had to exclude the endpoints because the endpoints are not included in both. So BC open-ended segment would go here. For the next one, angle IFG, which is this angle right here, and angle EFH, which is this angle here, I'm looking for the intersection. Now, in both, as you see, everything on this purple angle is not included in this green angle, and vice versa. The only thing they have in common is the vertex F, which is included in both of those. And so, because it's the intersection, I'm looking for only those that are in both of these figures. It's only point F, so that's what comes down here. The next one, open-ended ray FI, which is this one here, and ray FG, which is that ray there. Now, since F is included in this ray, and I am looking for a union here, it's going to be this entire angle that's highlighted in red, because although F's not included here, it is included here, and because it's a union, it's going to include it because it belongs to at least one of the sets. So this, as a result, would be the angle that I have here, which could be called IFG, or as we have it here, GFI. For this union down here, BC being the union with CF and the union with FB, here's BC. Now notice that the endpoint includes B, but doesn't include C because of where this is being shown. Same thing with CF, open-ended here. It got closed in here, because CF does include it, and FB includes F, but doesn't include B. And since I am dealing with unions here, I can include these points, although because, in each one of these instances, it's the points included in one of these segments. The point F is included, not in this segment, but in this segment it is. And if it's included in one of those, it's included in the whole thing. So as a result, this triangle, which we could call many different names, but BCF is one of them, is that union. And the point C intersected with CH. Obviously, by process of elimination, it's going to be the empty set, but here's why it's the empty set. Here's point C. Here's the open-ended segment CH. This includes C. This does not include C. So there's nothing that these two have in common. There's only one point in this set here. There's multiple points in this set, but they don't have any that are in common. And because it's an intersection, then I would have to say, okay, well, there's no empty set. If I was going to say if it was a union, then I could say that the union would be basically this with this dot closed in or not, no open dot indicated. The next problem, example 2, you were asked to find the measurements of angles 1 and 2, given that they are supplementary angles in the picture there. Now in the picture, you can see that the two angles, 7x minus 12 and x, form a total of a straight line. So in being supplementary, they have to be 180 degrees in total measurement. So if I take 7x minus 12, which is what measurement of angle 1 is, and x, the measurement of angle 2, they should total 180 as well. Which means I get the equation 8x minus 12 equals 180. Adding 12 to both sides means that 8x would equal 192. And dividing both sides by 8, I would get that x would equal 24 degrees. Now I have a couple of options to figure out what the measurement of angle 1 is. One of them is seeing, well, since angle 1 is 7x minus 12, I can just take the x value and insert it and calculate it out to get 156 degrees. Or since I know it's supplementary with angle 2, I can simply say, well, angle 1 has to be 180 degrees minus that 24 degrees, which is still 156 degrees. So whichever way you chose to do it is fine, either of those two ways, because they're relying on a piece of information that was determined earlier. For the second problem, example 2, you're given a very similar circumstance, except now angles 1 and 2 are complementary angles. And if they're complementary angles, that means the sum of their measurements have to be 90 degrees. And since angle 1 is 8x minus 9, measurement of angle 2 is x, that means adding these two together should also total 90 degrees. So I would combine the like terms to get that 9x minus 9 equals 90. Adding 9 to both sides gives me that 9x equals 99 degrees, which means that x would equal 11 degrees. And I'm not going to show both methods as before, and I don't even really show one or the other. I chose to go with the fact that they have to add up to 90 degrees, and for angle 1 and angle 2 to add up to 90 degrees, with angle 2 being 11 degrees, angle 1 had to be 79 degrees. So that's how I got to those. In example 3, you're given that you have a set of parallel lines. They're not telling you which ones are parallel, but you can kind of see from the picture. Oftentimes, to be on the safe side, they may mark them as parallel. And if you ever see any markings like that, just keep in mind it would look something along the lines of, a second set of arrows on the lines. So those two are the parallel lines, with this horizontal line being the transversal, of course. And you're asked to determine the measurements of angles 1 through 7. Well, there's different relationships that exist between each of these angles with the given angle of 120 degrees. Because there's two different intersections here, there's different rules that were reviewed in this particular lesson that you could use, depending on what you found first. So what I'm going to show here is one way you could have gotten through this, and the explanations as to why, but it's not the only way you could have gone through this. So the first thing I did is I noted that angle 4 was a vertical angle with the given 120 degree angle. And with that being the case, that means that these have to be congruent to each other, so the measurement of angle 4 needs to be 120 degrees. In a very similar nature, because they're at the same intersection, that means that angle 7 as well as angle 3 need to be congruent to each other because they're vertical angles, but they should also be supplementary with the 120 degree angle because the 120 degree angle in each one of those form a straight line. And with that being the case, that means that angles 120 and angle 3, as well as the 120 degrees and angle 7, they should total 180 degrees each one of those, which means that the measurements of angle 3 and 7 should be 60 degrees. Moving on to the next intersection, I have all the angles in this intersection's measurements known. I don't know any of these yet, but I do know because they are parallel lines there are some angle relationships between angles in this intersection and angles in this intersection. So I chose one of those relationships. So angles 6 and 7 would be congruent to each other, and they're congruent to each other because they would be corresponding angles. And since we already know that angle 7 is 60 degrees, that means that the measurement of angle 6 would be 60 degrees as well. Now, I could have used some other angles that were corresponding. I could have used some of the other relationships that were shown in that one box towards the end of the lesson too. So, keep in mind there's different ways I could have approached this. Now, angle 1 is a vertical angle with angle 6, so it must also be congruent. So, if it's congruent to angle 6, which I just shown was 60 degrees, this has to be 60 degrees. In a very similar way that I did for angles 3 and 7 down here, angles 2 and 5 are each supplementary to a 60-degree angle. If they're supplementary to a 60-degree angle, each one of them has to be 120 degrees. And so that's how I know the measurement of those angles are 120 degrees. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.